Good evening, everyone. It is once again Ted the Speed Learner, and tonight I'm going to continue my review of Math Doesn't Suck with the following. Danica McKellar, in this particular chapter of her book, tries to compare mathematical variables with foreign exchange students. Oh, this is going to get fun. This is totally unnecessary. As I have explained in several of my previous videos, in the last decade, all you have to do when it comes to variables is to imagine that a variable is a number wearing a costume. A better way to remember that is a famous video game that came out in the 1980s. Do you remember a famous video game that came out in the 1980s that had some ghosts in it? Okay. In the story. That should have been it. Just picture that, picture those ghosts in those costumes, and all you have to do is use every technique you could possibly come up with to get that costume up and see the number that's underneath. That's it. That's all you have to do. Why go through all of this when it's completely unnecessary? But it gets better. Alright. Now, I will agree that an asterisk, yes, that's a hard word to pronounce, an asterisk is what computer people started using for the multiplication symbol because they didn't really want to confuse it with the letter X. Okay? When you're multiplying things, you don't always want to use it. When you're in grade school and you're not using computers very much, letter X is fine. But when you get into algebra, this is a kind of a first step into algebra, you have variables that are X, and then you have this multiplication symbol that's also an X. And then, of course, you have the Latin number 10, and, of course, it's represented with an X as well. So that can be a bit confusing. So I do agree that an asterisk is a multiplication mathematical symbol, especially used in computers because you don't want to confuse it with the letter X. Okay. And I will say, although it's rare, when you're using the mathematical parentheses, you may have something called the FOIL method of mathematics. I have covered this in previous videos. I will do it again. Okay? So if you're using the FOIL method of mathematics, it's probably a good idea to remember that these parentheses are multiplication. So what you would do is you would multiply the first terms like this. You'd multiply the outer terms, okay? And then you'd multiply the inner terms. So these would be this and this would be the outer terms. This and this would be the inner terms. And then you would multiply the last terms, which would be the 3 and the 9. And that's why it's called FOIL. I have seen that in the past, and that in the parentheses is a multiplication whatever. Now, there is something else that is used for multiplication, and it's called a coefficient. And I really need to do a video about coefficient as to why they are called coefficient, so on and so forth. But let me show you this. When you see 3x like this, that 3 is a coefficient right there, and it is multiplied by the x. So yes, in these kind of situations you would not see a multiplication symbol. It would just be 3x. Okay? So Danica McKellar is correct. You would have that like that. So if you're using the FOIL method of mathematics, you would use the parentheses for multiplication. If you're using coefficients, of course, there is no multiplication symbol. Otherwise, the X and the asterisk are used for multiplication symbols. So much for that. After Danica McKellar finishes her multiplication symbol discussion, she returns to the foreign exchange student. In her illustration, the student offers up a nickname. Now, nowhere in this description of this foreign exchange student is it ever said that somebody called him that nickname. So apparently he's just come up with this by himself. Usually, when somebody decides to call you a nickname, they come up with a nickname, not you. Now you say, well, you came up with the nickname of Speed Learner. I didn't come up with the name Speed Learner as a nickname. I came up with it as a handle like you would find in the CB handle days of the 1970s. In the 1970s, everybody had a handle. I came up with a handle. That is not a nickname. That is a handle. That's different. Okay? So, usually these nicknames are given to people that are either their friends, because friends can give you a nickname, or maybe you have somebody that's a potential adversary, and they give you a nickname to try to humiliate you. Okay, so if you look historically, that's usually how it works. It's very rare when you end up giving yourself a nickname, but whatever. Anyway, at this point it doesn't really matter, but why she included all this, I don't know. Really, I don't know. Variables do not need nicknames. They are simply ghosts with costumes, okay? Take the ghost costume off, boom! You find the number. That's how it's done. Anyway. Then Danica McKellar presents yet another illustration. She discusses makeup bags, okay? She specifically refers to items in the makeup bag. In this particular case, she was referring to lipstick tubes, okay? Now, the question is, are all the lipstick tubes in this bag the same shade of color? Or are they different colors? She never specifies. And if the person's removing the lipstick from the bag, you have to ask yourself, how will they even know what colors are in the lipstick? Are they reading each and every one? Or somehow they just magically recognize that? Or are they all the same color and they just reach out and grab 3 and say, hey, there you go, I needed 3 of the same color? None of this is specified in her illustration. And then I'd like to know when Danica McKellar became such an expert in magic. I didn't see that on her resume. I know that she has been an actress. I know that she has been a book writer, obviously, but magician, I have not seen that one. That's a new one for her. Okay. Now, unfortunately, I will say first, before I go on, that the illustration that she's using can help people visualize word problems. So on that part, just that part alone, I will give her one kudo. Yes, this is a good training exercise for word problems. I'll give her that. But the rest of it is like, it's unnecessary, but okay. What should you use for variables? Well, what you really should use is Koine Greek letters, because that's what's used in higher level math books, including calculus. You'll see a lot of this, where they will use the Greek letter theta, or the Greek letter beta, or the Greek letter alpha for some of the variables in some of the things you're working on. Especially in geometry, you'll find this out. Okay? Because geometry and calculus both use Greek letters. So this would be an excellent time for you to memorize Koine Greek letters. In Danica McKellar's next illustration, she grabs a bag of pearls. Why? Again, there's no reason to substitute variables for bags of pearls. None whatsoever. Many young ladies in the United States simply don't possess and may never possess a sack of real pearls. They may have a pearl necklace that their mother or their grandmother gives them, but entire sacks of pearls? Really? What do they do? Live right next to an ocean where they can pick up a bunch of oysters and pull out a bunch of pearls? What are they supposed to do with the rest of the oyster, huh? Give it to their brothers or give it to their dad so that he can cook them up? So, and let's say that they're fake pearls. Okay, fine, I got that. It's very unlikely that young ladies will have real pearl necklaces. It's very unlikely. But, whatever. If we proceed with this particular illustration, we will find ourselves counting lots and lots of pearls. Again, this is unnecessary. Again, I will go back to the ghost of the video game and say, all you have to do is pull off the ghost costume and find the number. That's it. That's all you have to do. All this extra stuff was completely unnecessary. Now, on the other hand, Danica McKellar comes up with a scale illustration, okay? I wanted to tell you guys that I actually do have a pair of scales, but I have lost them. I moved and I lost them and I don't know where they're at, and as soon as I find them I'll use it for future illustrations. But for tonight we'll just have to go with this. This is a pathetic looking thing of scales. I do agree with her illustration at this point because you do really need to know this. This part you really do need to know. Okay? And she is correct in saying that whatever's on one side of an equation, if you got an equal sign, the other side has to have the same amount. That she is correct on. And using this pair of scales was a brilliant idea. Okay. But you do not, under any circumstances, have to substitute variables with bags, boxes, foreign exchange students, or anything else. Okay? And you don't have to rename algebra. Okay, and that's something that we'll cover in a later video. But she decides that she wants to rename algebra because what she wants to do is send you to an amusement park. Why? It's unnecessary. Absolutely, totally unnecessary. Complete waste of time. But anyway. So, again, I'm going to advise use Greek letters for variables. That's it. Now, a better way to illustrate moving things from one side of an equation to another side of an equation is to imagine a moving truck. Okay? And a lot of people have seen moving trucks. Trust me. So, just make sure you place the same amount in the moving truck. Okay? So, whatever you place in the moving truck, don't take it back out until you get it to the other side. Alright, so we're going to illustrate this. Let's suppose you have an equation (3x plus 1 equals 10). Now we're going to take 1 away from this, so we're going to put that 1 in a moving truck. And we're going to move it over here, we're going to add it to this. So now we have 3x equaling 11. No. Nope, that's 11. Sorry. Nope, wrong. Because we're going to subtract 1 from both sides of the equation, so that is actually 3x equals 9. My mistake. Wrong. Okay? We're subtracting this. We're going to move 1 away from this and 1 away from this side. And then you divide it by 3. And you get x equals 3. So if you subtract 1 from this side of the equation, you have to subtract 1 from that side of the equation. And that's the part I got wrong, and I'm sorry, and you can beat me up for it. Let's go ahead with another equation. Now, Danica McKellar is also correct in stating that you should always isolate your variables. Just think about a party where you see someone in the corner who isn't enjoying the party very much. Have you ever felt that way? Just think about the poor variable once it finds itself in a corner. Then Danica McKellar presents a testimonial. So, who's the person of the testimonial? Well, I'm going to let you read that for yourself. But this particular person states that the only way to succeed in mathematics is to study hard. That is a lie. Okay? There are other ways. You just need a very good guide like me to help you find your path. That's why I'm here. By the way, you should never compare your grades with the grades of your peers. You're basically comparing yourself with others, and that's really not a good, healthy thing to do. Remember, you are not them. They have their own problems. Let them have their own problems. You don't live like them. You don't study the same way that they do, so don't think yourself like them. The person in the testimonial states that she was hard on herself despite her exceptional grades. Why? If you feel that way, feel free to talk to your friends about your grades. I can almost guarantee that there will be at least one or more of your friends that would be envious of your grades. Once you see the envy in their eyes, you will no longer be tough on yourself. It's that simple. If you're really struggling with your math problems, I recommend coming here and seek my assistance. I'm always available. It's highly doubtful that your friends are going to successfully assist you, especially if they are struggling with mathematics in the same way as you are. And that's all I've got to say. Alrighty. I want to thank you very much for watching this particular presentation. If you want to beat me up, that's fine. For getting that equation wrong, that's fine too. But anyway, I appreciate you coming here tonight and taking a look at this. I will tell you more in a future video, so I'd like for you to stay tuned.